Hey everyone, we're going to do a problem from 1D motion. This is in the slides. It's about a rocket getting launched upward. It is accelerating for 30 meters at a rate of 30 meters per second squared for 30 seconds, and it runs out of fuel. And the question is, what is its maximum altitude? Okay, so let's set this up. So we are given that our acceleration is 30 meters per second squared. We know that that goes on for 30 seconds. We know that it accelerates from rest, so my v0 is 0. And so let's draw a picture to see, kind of visualize what this looks like. So here's my ground and my rocket. Very sophisticated drawings here. And so it's going to accelerate upward, right, to some altitude, let's say right here, at 30 seconds, right? And then after that, it's going to keep going up and eventually stop just due to the influence of gravity. So in terms of a motion map, what that looks like is, first it's accelerating due to the rocket fuel, so my points are getting further apart. Okay. And then at this point, the fuel runs out, and so, but it still has a velocity, so it's still moving upward. It's just going to be going slower and slower and slower, and eventually stop, let's say at the top. Okay, so again, here's the point where it's transitioning. So I'm going to call this my 0 point, I'm going to call this 1, and I'm going to call the top 2. And we'll try and relate all of those positions. So what we want to find is the max height. Okay. So in the first part, we know our acceleration is upward, right? And then here we have our acceleration from gravity, it's downward. And I'm going to create my coordinate axis right where the rocket launches. So that's my plus y, and that's my plus x. It's only 1D, so I don't need to worry about x right now, but we have it there just because we'll be moving in that direction eventually, right, in the next chapter. Okay, so how am I going to solve this? Well, I know time and I know acceleration, and so I can actually calculate my distance traveled to the point where the fuel kicks off, right? So if I want to know, so first thing I'm going to do is find y1, let's say, the y value at 0.1. That. Okay, so the general relationship is y final is y initial plus v initial t plus 1/2 ay t squared. What I'm actually going to relate this to my points now. So my final here is y1, my initial is y0, the initial would be v0 t, and then 1/2 ay t squared. So my initial velocity at this part is 0, my initial height is 0, so we cross those out. And now if I want to know what my height is at 0.1, it's just 1/2 my acceleration, 30 meters per second squared, times my time squared, 30 seconds squared. Okay, kind of did this out already in Python, right? So it's 0.5 times 30 squared, so I get 13,500 meters. Okay, so now at that point, I also want to know what my velocity is, because I'm going to take this, once the fuel ends, I'm going to take it almost as a separate problem, that I have an object that's starting at some height with some initial velocity, and now it's just moving under the influence of gravity. So to get my velocity at 1, I'm going to use the relationship that v final is v initial plus acceleration times time. So my final velocity is going to be v1, my initial is v0, and then my acceleration times time. Again, v0 is 0, so that goes away. So v1 is 30 meters per second times 30 seconds. So that's 900, seconds squared, sorry, I messed that up. 900 meters per second. Okay, so these are kind of in between answers, but good to box them off. Okay, so now fuel shuts off. So what happens? So it's going to actually, it's not going to just fall down immediately. It's going to keep moving up until that velocity has decreased enough that it stops. Okay, so we want to figure out how high it goes. So there's always lots of ways that you can do this, right? We could solve for, we know that the initial velocity at the top is 0. So I should put that in here, right? Because we know that it stops at the top. So I could solve for time and then use my position versus time. Or I could kind of do it all in one step if I use this relationship that v final squared is v initial squared plus 2a delta x, so delta y in this case. All right, so v final in this case is v2 squared. And my initial is the velocity at v1. And now my acceleration is gravity. I'm going to put the negative sign in here, right? So I'm going to say my acceleration is negative g, which is negative 9.8. And this is 1 to 2. Okay, so we know at the top, the velocity is 0, and I want to solve for how much higher it goes. So I'll get that by itself. So delta y is negative v1 squared divided by negative 2g. Okay, so our negatives go away. We get our v1, so that is 900 meters per second squared, and I'm going to divide by negatives already canceled out, so I'm going to divide by 2. It's 9.8 meters per second squared. So if I look at my, I already did that out, so 900 squared divided by 2 divided by 9.8. So I get my delta y is 4,300 meters. We'll just keep 3 significant figures for now. And let me check our units. I get a meter squared divided by second squared on the top, and on the bottom I have meters per second squared. So the seconds cancel out, one of the meters cancel out, and I just have meters over there, so that's good. Okay, so now just keep in mind that this is, the delta y is saying what my positions change between 1 and 2. So if I want my final height, I have to add those together. That's y1 plus delta y. So 13,500 meters plus 41,300 meters. I add that up, I get a 0, a 0, an 8, 4, and a 5. And that is pretty high.